Yeah, we're going to talk to you about Archer Daniel Midland's and some series of deployments they did on the edge that involved fog lamp and Pi and had some great results. And so most of the presentation is going to be by Francis. Francis is, he's been a Pi administrator since 2003. It's almost 20 years. And actually did his first Pi World presentation in 2007. So he's an old hand to this. And he also makes a mean waffle cookie. So if you meet him afterwards, you want to get the recipe for that. I'm Bill Hunt. I'm the CTO and co-founder at Dynamic. And we make fog lamp. And I'm going to turn it over to Francis in just a second. But and then after Francis is done talking about the deployment, I'll tell you some of the details of how the technology worked behind the scenes. And just very quickly about Dynamic, so kind of what we believe. We're all about Industry 4.0, and Industry 4.0, of course, is all about intelligence. It's all about data and the processing of that data in the industrial world. And we believe that the closer you can push that intelligence out to the edge, where the machines are, where the people are, the more effective you can be. And of course, sustainability is a key part of what we think about. And I think that us and the people in this room are in a unique position to make the world better. So we think that's important. Dynamic, we make Fog Lamp as our core product. Fog Lamp is the software that runs out on the edge. And Fog Lamp Manage is centralized management that enables you to manage thousands of deployments of fog lamps. We are based on open source software, and we're the world's leading open IoT, intelligent IoT platform. We were founded 5 years ago, 2017. Myself and my co-founder sat down with Pat Kennedy, who is the CEO of OSIsoft, and he convinced us that this would be a good thing to build, and we agreed. And OSIsoft and AVEVA have invested money in Dynamic towards this end. And Pat Kennedy was on our board, and now Ronan Dehuj is on our board. And we also are now have an agreement with AVEVA, where AVEVA is an official reseller of Dynamic. So we're very excited about that. So we encourage you to talk to your AVEVA people to learn more. And here's Francis, and ask him about those waffle cookies.
All right. I'll start about ADM. Before I do this, Bill is on the podium with me. I do this presentation. I'm not the only one that actually worked on the whole project. I have Shane Bagas and Gopal sit on the front row. They are big contributors on what's happening and what we actually present. So ADM, the purpose of ADM is to unlock the power and to enrich the quality of life. And we believe that everyone has the right to the food they need to sustain their lives. Food derived from nature is important. It's an important driver for health and wellness. Access to nutrition has the power to solve many of the world's challenges. At ADM, we transform natural products into a complete portfolio of ingredients and flavors for food and beverages, supplements, nutrition for pets, livestock, and a lot more. And with an array of unparalleled capabilities across every part of the global food chain, we give our customers the edge in solving the global challenges of today and tomorrow. One of those capabilities is using data analytics to improve our manufacturing processes, including edge solutions. All right, ADM by the numbers. I'm part of the Focused Improvement and Analytics Center of Excellence. And we have a growing team that is investing in edge technology to help our 800 facilities, 300 food and feed processing locations around the world in more than 200 countries. And we try to use our data to make better decisions. The challenges that we started with was to increase the yield and the quality of our oil production and reduce the waste. For a solution, well, we started examining edge technology to see if we could capture the data we did not have before. And then use that data to analyze and see what we could do. We partnered up with Dynamic using their IoT platform, FogLamp, and their machine learning. They integrate the machine learning with the Pi system, and we integrate it with PyIF and with the Pi server, okay? Benefits, it's hard to, we can't put a number up there, but in addition to all the hard savings that we had right away, we had a lot of other impacts on the initial projects. We had safety, OE, and so on. Combining the Pi system, FogLamp, edge technology, we are working on increasing the yield and the quality, right? But we're also improving safety, operation. We drive the operation to be more efficient in a sustainable way. All right. What's FogLamp? FogLamp is an open source intelligent IoT platform. It collects, processes, and integrates machine sensor data with the OT systems like Pi and the cloud. Okay? FogLamp supports edge-based machine learning, and it's building and executing the models on the edge, right? Most of the machine learning today is based on cloud, and it uses very large sets of data to do that, right? But when we're using machine learning and other high fidelity data like vibration, video, the latency and the data volume are limited, and the control requires models, that how do we do that, right? So we combine, so IoT is actually a new vital tool to us, and it actually complements our DCS and our SCADA. And at ADM, we've got a lot of remote assets, like grain silos. We've got barges on the river. We've got ocean ships. We've got all kinds of remote assets. You can't connect those to the DCS. I've never seen a boat with a wire going to the DCS, right? So in plants, we have assets like infrared cameras. They're detecting, heat. They're also not connected to the DCS, right? Anybody's got infrared connected to the DCS? Don't see hands. So our new edge machine learning applications, they require also a lot of bandwidth, right? Processing, memory, things that our DCS was never designed to do. So in order to handle all that, we're using Pi, we're using FogLamp, we combine everything, getting all those sources together, and we create actually, what we call transparent factory, okay? All right, now I'm gonna go quick into 5 use cases. I'm not going into detail because we don't have that much time, but I'm gonna try to show you what we did with all this. So one of the first proof of concept that we got challenged with were skid scales, right? In research, they had some scales. They could talk OPC, they could talk Modbus, not connected. Well, we achieved data collection with FogLamp, and we used the South plugin, OPC UA, connected it, it worked. And we used the South plugin, Modbus, connected it, and it worked. And we just picked one of the two. Also what that did when we started with the scales, we used OMF Nord plugin to get the data to the Pi server. And so it created automatically Pi tags for us. It put the stuff in AF, in a hierarchy, and we were done. The second one I'm talking about is grain silos. Grain silo has a lot of cables, temperature cables in there. They have at each level. They measure the temperature. Could be easily 1,000 temperature measurements in one bin. So how do you collect that data? So we have a proprietary software that actually did that for us. It's with multiplexer, it's very complex. And so that data goes in their software, but it's proprietary, you can't get it out unless you export it to a CSV file, right? Now you could use UFL, right, to read that. But we were, since this is edge technology, we want to do that right on the edge. We use the CSV playback South plugin. Again, very simple. Connect it up, the CSV file comes, and Fog Lamp actually gets it out to the Nord in OMF format, right? But we couldn't do it in MQTT as well. Send it to a data hub, for example. Another project that had received traction right away when we started looking at it was FLIR infrared cameras, right? As soon as we started doing that, we used the FLIR AX8 South plugin. We configured it. Data went to the Pi server through OMF. And I also have an app with MQTT, so I can see the data. It streams parallel if you need to. So that's pretty cool. And we tested that with a low-end camera, not much configuration, can't do much with it, but still the data goes to Pi. And we used a high-end camera as well, which could do actually everything. It had Fog Lamp built in the camera. So it could do MQTT from the camera itself. So if you don't have a network anymore to the Pi server, the camera was everything doing. Then in our quality, and this is a project that is still ongoing, that we're still working on, is the near infrared. So that's more like, it's on the equipment, it's on the machine, it reads the near infrared, and now you got to do something with it. Previously, the data would move through different layers. Somebody would get an advice, it goes back down, and you got to control something. What we are doing now is we're actually going with near infrared. We're going to, there's a machine learning model sitting on there. It scores the model right there, and it controls. So it doesn't even go away from the machine. Everything is done at the machine. And then the last one is basically the centrifuge. That's basically in the category of quality. We can bring up, let me see here. The last concept is monitoring of the centrifuge with high frequency data coming from accelerometers. And this is to detect anomalies during the operation and to improve and get the machine going, right? So there's 4 accelerometers on that machine, on that centrifuge, 60,000 data points per second. 60 points per millisecond, right? So we process that on the edge. Here's, I'll quick go through a little thing. This is displayed by vision. And because this is the grain silo, the temperature, and because it's structured in AF, you can actually use collections in AF. So basically all these squares you see is one temperature probe. but because it's collections, it's only one square displayed in that array, okay? So that took me about 10 minutes to create. Here's our infrared camera. The person that's there, it's not live, but that's Copal. That's our setup in the lab. And you see we have 4 areas, and each area has a maximum temperature, and that's displayed in Pi Vision, okay? That setup was done in less than a minute. We operate a larger quantity of centrifuges, and machine learning is helping us to convert and transfer that knowledge from one to another. So it's not only capable of, for us to tell, it tells us the health right away, but it does a lot more. It provides us insight in the operation of the machine, combined with the data from the PLC, combined with the manual entry from the operator. And again, we're going there to the transparent factory. I tried to find the new name. The return on the investment here, again, when we started that, we had the money back within 3 months. So less than 3 months, we had return on investment with the installation. And I gotta move on because he needs to talk to him. We got 3 minutes. So this is the thing that my boss said. I'm gonna let it read to you, but I'm gonna hand it over to Bill, who can go to the next steps.
I would almost rather to hear Jennifer's quote than what Bill has to say.
All right, okay. So what my boss said, the Expo Insights at Fog Lamp Edge I always go to manual logger. Machine learning has delivered to our centrifuge team is a game changer, or are a game changer. And with the support from Dynamic and AVEVA, our ADM team has been able to confidently improve the centrifuge process without concern of any negative consequences. So that means we implemented and we didn't run any risk.
Cool. Thanks, Francis. I'm going to skip through a couple slides. We're running a little bit short on time. But there's some good stuff here. If you'd like to come by the Dynamic booth, happy to tell you some more. So I'm going to focus on the centrifuge project that Francis talked about. So what happened with the centrifuge project? As he said, they attached some vibration sensors to them, and then they processed the data that they collected with it, and they then built some machine learning models, and then they were able to have a health metric that let them see what was going on inside the centrifuge. And so mechanically, they had vibration sensors that connected to the centrifuge, and they also connected to the PLC with Ethernet IP. And that flowed into Fog Lamp where the models are running, and then the data flowed out to a AVEVA Pi server. And part of the training was done in Google Cloud. And come by our booth and I'll tell you about that. There's no way that's happening in a minute 20, minute 12. But real quick, this is the Pi dashboard, the Pi Vision dashboard. And the yellow metric is the health metric. And so it gives a sense of what normal activity is and abnormal activity. And the higher, the more abnormal. And you can see a spike in the middle there, and that told them that there was something they needed to take a look at. And it isn't just, so this is very valuable for, call it predictive maintenance, where you, when you see that number go up, then you need to take a look. But it also gave you a sort of a real-time view. And so that's kind of important, because if you look at the bottom thing, if you look close, you can see on the left side that the lines are closer to each other, the purple bars on the bottom. They're closer to each other on the left. And what happened was they would do this process called a shoot every so many minutes. Why was it that number of minutes? Well, nobody really knew. It just had always been that way. But what they were able to do after this was they were able to try tuning that, and then they could very quickly get feedback if that was the appropriate shoot time. And then shoot times could change based on how green the beans are, or you can imagine other things. So in time, we expect that there's a lot of extra valuable things that can be done with that metric. So in conclusion, I have 0 minutes, but let me real quickly say, ADM, we're so proud to have worked with ADM and the great people there. They wanted to increase their yield, quality, safety, sustainability, get all their data into the AVEVA Pi system, and they were able to do that, leveraging some of the technology we provided. And we're so happy that Jennifer said that we are a game changer in all that.
One thing I want to say is the first time we turned the machine learning on, we found out right away was it a bearing that was broken, and we changed it out.
Yeah.
We turned it on and we found the problem first second.
Yeah. Pretty cool.
All right.
So that's what we have.
Bill. Thank you very much.
Thank you.
Thanks, Bill.
Thank you. Oh, actually, I should.
All right, we have about 4 minutes for questions. So if you have one, please state your name, your company, and ask your question. Here's the board.
Hi, Martijn, Healing Data. Great presentation, guys. I'm always on I love the custom vibration monitoring. I always wonder when you make the decision to buy something, or is it a really specific characteristics that you could only solve by yourself, or buying a vibration monitoring off-the-shelf solution?
No, we actually got advice by Dynamic. They actually said, hey, these sensors are good sensors. We were looking at a certain frequency, which I'm not going to tell you.
Oh, that's fine.
Secret. No, where.
That already answers the question, right?
Yeah.
So this is good.
And so we do have 2 different sensors on the machine. They're 2 different ones, and we're looking now to expanding this. We're expanding this to more centrifuges. And so we actually, we're looking at which sensor would be the best to keep going for. But we tested out 2 different sensors, if that answers the question.
One here.
Nasir Adnan from Invista. So in the presentation yesterday, there was a topic about Pi adapters. I'm wondering, how does fog lamp compares to Pi adapters?
Yeah, I would say you can kind of think of fog lamp as like a connector on steroids. So there's so of course the connectors are much more tightly integrated to Pi. They're part of the Pi ecosystem. So there's definitely an advantage to those in the places you want to use that. Fog lamp, the advantage is that you can do a lot of more beefier math, right? You can do machine learning things. You can do signal processing, FFT, machine learning on top of FFT. You can also, because the source code is open source, it's very easy to connect to anything that doesn't already exist. We have hundreds of things that it can connect to, but in fact, if you have something new, it's very quick to get something new out to it.
Congrats for the presentation. My doubt is regarding infrastructure. I saw a lot of sensors connected to the fog lamp, and my doubt is, did you use the same infrastructure, network infrastructure, or it was necessary to create a new one?
I'm sorry, do you mean like the actual networking infrastructure?
Yes, to connect the sensors to the existing fog lamp.
So the data, the